Today we'll be learning factoring to solve quadratic equations. So first let's look at our quadratic equation and look how we can graph it. So if we take this and we find our axis of symmetry, we're using the opposite of b divided by 2 times a. So our opposite of b is a -3. And 2 times our a, which is a 1. So we end up with -3 divided by 2. So our axis of symmetry is at a -1.5. So my axis of symmetry is at -1.5. So now let's find our vertex. So I know our vertex is going to be at -1.5. So let's find where it's going to be at for the y. So we're going to take -1.5 and square it, add 3 times -1.5, and subtract 4. So when we type that in, do -1.5 squared plus 3 times -1.5 minus 4. We end up with our y being a -6 and 25 hundredths. So if we graph that, -1.5 down to -6 and 25 hundredths. So there's our vertex. So let's find our y-intercept. So it's just going to be at 0, -4. We reflect our point over. So when we go and graph, looks like that. So it looks like, no, it's not as completely accurate, but it looks like we're going to have a solution about 1 and around -4 based off what we've drawn so far. So let's look at factoring. We factored before in our last unit. So if we start by factoring, we can take our x squared and place it in the top left, -4 in the bottom right. So let's factor 4. We have 1 times 4 and 2 times 2. So we want to end up with a positive 3x. So we want to use our +1 and a +4. Well, sorry, not +1, +4. But to get a negative or +3, we want to have +4x and a -1x. So in order to do that, if I combine my like terms, 4x plus a -1x ends up with 3x. So to factor, we know we have x and x, 4 and -1. So if we multiply these out, x times x equals x squared. X times our -1 is a -1x. X times 4 is 4x. 4 times a -1 is a -4. So that means we factor and we have x plus 4 times by the quantity of x minus 1 equal to 0. So if we set and solve each of these, x plus 4 equals 0 and x minus 1 equals 0. We know x will equal a -4, or x can equal a +1. Which if we look back at our graph, we had a solution at a +1 and a -4. So what is true about the relationship between the x-intercepts of the graph and the factors of the quadratic? Well, if we look at our factors, these are our factors. So we have x plus 4 and x minus 1. So they're actually the opposites, and the solution of the factors are going to be the same. Let's find the solution to the following equations. Where will the graph cross the x-axis? So here we take our first, we have x minus 3 is our first factor. So x minus 3 equals 0. We can add 3 to both sides. So x equals a +3. Or we take the other factor, which is x minus 7 equal to 0. We're going to have x equals a +7. So our x-intercepts, where across the x-axis, can be at a +3 and a +7. So now if we look at this one, our first factor is x. So we said it's equal to 0, so we already know x is going to equal 0. And then our other factor is x plus 1. So we set that equal to 0. Subtract 1. So we have x equals 0, or x equals a -1. So first factor in this next one is 7x plus 2. Set that equal to 0. Take our second factor, 5x plus 4, and set that one equal to 0. So we can subtract 2 to both sides. So 7x equals a negative 2. Divide by 7. X is going to equal negative 2/7. So here we subtract 4. 5x equals a negative 4. So when we divide both sides by 5, x is going to equal a negative 4/5. So here's our two solutions for that problem. So let's look at the steps for finding the x-intercepts of a quadratic function, or the solution for a quadratic equation. So first things first, we need to transform the equation to standard for equal to 0. So we want ax squared plus bx plus c equals 0. So in this case, we started equal to 0, so step 1 is done. So step 2 says to factor the quadratic expression. So if we fill out our box, we're going to do x squared negative 10. So if we find all of our factors of 10, we have 1 and 10, 2 and 5. We need to add together to be a negative 3. So we're going to want to use the 2 and the 5. We're going to want a positive 2x and a negative 5x. So if we combine these two together, 2x plus a negative 5x does equal the negative 3. So when we factor, we're going to have x and 2, x and negative 5. So our factors are x plus 2 times by the quantity of x minus 5 equal to 0. So once we have a factor, now we can solve to find our solutions. So we take the first factor, which is x plus 2, set it equal to 0. Take our second factor, x minus 5, and set that equal to 0. So our first solution is going to be x equals a negative 2. And our second solution will be an x equals 5. Alright, so let's look at this next one. First of all, step 1 we're going to have to do because it's not equal to 0. So I'm going to subtract 2x squared to both sides, and I'm going to also add my 2x to both sides of the equal sign. So 3x squared minus 2x squared is 1x squared. 4x plus 2x is 6x equals negative 9. These become 0. So the last thing I need to do is make sure I add 9 to both sides. But in this case, 9 is not a like term, so we're ending up with x squared plus 6x plus 9 equals 0. So now we're using this quadratic function. So first step, let's factor. So we have x squared and 9. Factor 9. So 1 and 9, 3 and 3. So we want to have them add together to be a positive 6. So that means we want a positive 3x and a positive 3x. So when we factor this, we're going to end up with x plus 3 times by x plus 3, which is really x plus 3 squared. So we're going to only end up with one solution. So when we solve this, x plus 3 equals 0, our one solution is going to be x equals a negative 3. Alright, let's take a look at this last one. So we want it to be equal to 0. So I'm going to move my 2x to the third to the other side, so this side will become 0. So negative 2x to the third is going to be, we're going to subtract. So 0 equals negative 2x to the third minus 2x squared plus 40x. So first, before we can factor using our box method, we have to do the greatest common factor. So the greatest common factor between 2, 2, and 40 is 2. And as well as x, we can take out 1x. So when we factor this and divide each of them by our greatest common factor of 2x, we're going to end up with, excuse me, a negative, well, actually we're going to factor out a negative 2. We're going to end up with a positive 1x squared, a positive 1x, and end up with a negative 20. So now we can use our box method to factor. So x squared, negative 20. So if we factor 20, 1 and 20, 2 and 10, 4 and 5. So if we need to end up with a positive 1, we're going to be looking at the 4 and the 5. So we're going to want a positive 5x and a negative 4x, because if we combine our like terms, 5x minus 4x is a positive 1. So we have x and 5 and x and a negative 4. So when we factor, we have x plus 5 times by x minus 4 equals 0. So then to solve, x plus 5 equals 0, x minus 4 equals 0. So we subtract 5, so x equals a negative 5, or x can equal a positive 4, but we also can't forget this negative 2x over here, so we also have negative 2x equals 0, and when we divide 0 by negative 2, x also equals 0. So we end up with 3 solutions: x equals 0, x equals negative 5, and x equals 4.